So in the last video, we were working on rotating this curve y is equal to e to the x around this y-axis and finding its surface area, and we ended up integrating with respect to x. But during that video, I said, hey, and that's just the decision that we made. We could also integrate this with respect to y. So I wanted to show you how you would set this up, integrating this with respect to y. And again, the important point that I wanted to stress in the last video in making this decision or whatever is the fact that we rotated around this y-axis here means that our radius is x. The radius of all these horizontal slices here for these circles that we have is x. But how we represent x is determined by how we want to talk about this little piece of arc length, whether we want to express that in terms of dx or dy. So, and the same thing is the case here when we're rotating around the x-axis, but instead our radius would be y then. And again, we get to decide how we want to represent y, and that's dependent on how we represent our piece of arc length. So let's just show that we could integrate this similarly with respect to y, and I want to show you what that looks like. So again, this right here would be multiplying by ds. But since we want to integrate with respect to y, x now is going to be, we're going to need to solve y is equal to e to the x for x. So we can do that right here. Y is equal to e to the x. And then solving for x, we get the natural log of y is equal to x. So that's what we're going to write here. This is equal to 2 pi. And then we said that x in terms of y is the natural log of y. And now what we're going to do is solve this little piece of arc length and have it in terms of dy. So let's come down here. And then instead of factoring out a dx squared, we're going to factor out a dy squared out of this radical. So we're going to have ds now is equal to the square root of, and this is going to be dx dy squared plus 1 and then dy. And now what we need to do, we found what x was. We said that x is equal to the natural log of y. Now we're going to differentiate x with respect to y. So here we go. We have dx dy, our derivative of x with respect to y is equal to, and then taking the derivative of ln of y is just going to be 1 over y. That's what we have for our derivative. And now all we're going to do is plug this back in. Here we go. So we can now write that, actually, let me scroll up. We'll put it up here. Put it right here. We're going to say that ds now is equal to the square root of, and we found dx dy to be 1 over y. And then we're going to be squaring that, and then we have plus 1, and then we can't forget dy. Now, we can take this piece here, copy paste, and then we'll move it up here. This piece right here, all of this now becomes our little piece of surface area. And again, all we need to do now is throw this into an integral. So let's do that. Let's throw this into an integral. We'll have now the definite integral, and we'll save our limits of integration for last year. We'll have 2 pi times the natural log of y times the square root of, we have 1 over y, and then squaring that, so that's going to be 1 over y squared plus 1, and then we have dy. And what are our limits of integration going to be now? Well, we said that we're interested in x from 0 to 1, and if that's the case, then y is going to range from 1 to e. 1 to e. Those are our limits of integration when we're integrating with respect to y. And what you could do is further simplify this integral a little bit if you'd like, but this right here is going to be our integral. This right here is our definite integral. And all I wanted to show you is that we could set this up with integrating with respect to y. It doesn't have to be with respect to x. But again, the important part to remember is when we're rotating around this y-axis here, these horizontal slices, their radius is going to be x, and how we represent x is determined on how we want to integrate. Do we want to integrate with respect to x or with respect to y? And that will determine how we solve for this little piece of arc length. So hopefully that clears up some questions that you had.